for you is Sofia.
Hello, my name is Sofia. I have a PhD in biochemistry, and today we're going to be talking about phosphorus. Phosphorus is a big part of life. It's in your DNA, it's in ATP, you can get it through eating milk, meat, etc. Please observe the phosphorus cycle. Transfer of phosphates through decomposers is called the short-term phosphate cycle. Decomposers break down living things. Living things take that organic matter and spread it back into the earth, where phosphates are then released into the water and soil. This pond is
Not a pond.
For scientific purposes, this is a pond. In a pond, excess phosphorus can cause excess algae growth. All of this excess algae will then die and cause oxygen to be used up. That oxygen is now gone, and fish and animals cannot survive. This is bad. This right here is a rock, and this right here is weathering and snow and rain and sleet and anything that weather can chuck at the rock. Then all of the phosphorus from this rock will seep down into streams or runoff and come into the lake, in which algae growth will bloom. Phosphate ions in rock can only be dissolved by things containing water, like snow, rain, and ice. These ions can then be used by photosynthetic organisms to be spread back into the ecosystem. Let me do a pull up. This is known as the long-term phosphorus cycle. We're here with Hannah KP, who wants to talk about the universal solvent, hydrogen bonds, its melting and boiling point and density. Hit it.
Hi, I'm here today to make iced tea to show you how water does its thing. Now I'm going to be boiling some water. Did you know water is a high boiling point and a high heat capacity? Heat capacity is the amount of energy needed to change a small range of temperature. Water has a high heat capacity because of hydrogen bonding. Hydrogen bonds are the weak attraction between hydrogen molecules and oxygen molecules. Only when hydrogen bonds start to break can water boil. After hydrogen bonds break apart, a phase change occurs from liquid to gas. Density decreases as water heats up. This is known as thermal expansion. Water is different from all substances. When it freezes, it expands to form ice. Hydrogen bonds in ice hold the water molecules open in a crystal-like structure. As water starts to cool, it becomes more dense. It is most dense at 4 degrees Celsius. This is a lake, and this is nutrients. As water sinks and rises, nutrients are cycled along with. Same goes for water in plants. Adhesion provides an upward force on the water, and cohesion attracts the molecules to one another. Adhesion and cohesion are just another way of talking about transpiration. Transpiration brings water up through the xylem and out to the leaves.
Now for a quick slam poem about the hydrological cycle.
Evaporation! Condensation! Precipitation! Runoff!
Transpiration!
Infiltration! Cellular respiration! Storage!
Transpiration releases water, plants remove their sweaty clothes. Cellular respiration gets rid of water through the skin of animals' nose. Evaporation changes state and makes a gassy mess. Condensation holds that cloud and gathers all the rest. Precipitation drops that base and lets the water fall. Water runs off to the lake where fish can feel it all. Infiltration seeps in deep and leaves the water underneath. What's water quality like in your home? I need to test the water quality.
What? What for?
No, it's for finding out. It's for a survey.
Oh, okay, come in.
Oh my goodness. The water quality.
What's that?
Rats. Your water. Your water. I knew it. It's okay.
But why?
Because it passes all of the chemical, physical, and radiological tests.
But why do I need my water to be good?
Because you use it for everything. Alberta uses for their industry, for their irrigation, for human consumption, and for recreation, like a pool. Aren't you gonna say thank you?
Okay, bye.
It's like Mexico out here. I wonder why it's so warm right now. Solar energy from our sun hits our atmosphere, and 70% is absorbed by our Earth, 30% immediately being reflected off. After the heat is absorbed by the Earth, the excess heat should go back up into outer space, but things like greenhouse gases like carbon dioxide and methane trap it. This is natural, but excess can keep the Earth too warm. Some ways we can prevent global warming are by planting more carbon sinks, reducing methane and carbon dioxide emissions, stopping CFC's production, and stopping deforestation. Many people don't think about this, but nitrogen is a huge part of living systems. Plants need it to make proteins, and it makes up 78.1% of our atmosphere. Plants and animals can't use nitrogen from the atmosphere, so a process called nitrogen fixation has to kick in to make it adaptable for plants and animals. Some nitrogen-fixing bacteria live in a symbiotic relationship with plants. They provide ammonium for the plants, while the plants provide sugars for them to live. Denitrifying bacteria complete the cycle by converting nitrate and nitrate back into nitrogen gas. This is called denitrification! Plants and animals are broken down by decomposers and turned into ammonia. This is called ammonification. Afterwards, soil bacteria break down that ammonia into nitrate and nitrate. Look at all these humans! They're a huge part of the carbon and oxygen cycle through combustion of petroleum, burning fossil fuels, deforestation, and agriculture! Watches the primal teenage male frolics in his environment. He is taking in oxygen and releasing CO2 into the atmosphere. He is a high-level consumer, and he does this as any primary consumer would. Photos of the synthesis kind, or photosynthesis, will release oxygen and take in CO2. This occurs in things like trees, grass, algae, etc. A carbon sink is a reservoir that absorbs more carbon than it emits. An example of this would be a tree, but the world's largest carbon sink is the ocean. The ocean contains tons of dissolved carbon. Today we're going to bring back some of our childhood by playing with Play-Doh to show you how acid depositation occurs. Burning sediments and rocks like coal will release sulfur particles. These will float up into the atmosphere and attach to water molecules. Once attached to water molecules, they will condense in the clouds and form sulfuric acid. This sulfuric acid will be released through rain and spread down onto the earth and can collect in rivers and streams. The rapid cycle of carbon. It occurs in the biotic environment. Trees store large amounts of carbon, and when they die and decompose, or forest fires occur, is when it's released. CO2 is dissolved in the ocean and released back into the atmosphere through evaporation. This is known as the other part of the rapid carbon cycle, the slow cycle of carbon. When organisms die in the ocean, like photosynthetic organisms, they're consumed by things like fish, whales, and zooplankton. And when these die, a small percentage of it is deposited into Earth's crust, which then turns into the petroleum deposits over millions of years. Combustion by humans can return this into the atmosphere. I found a bomb! Carbon! It's really hot! Let's talk about its rapid cycle. Carbon! Let's talk about its long-term cycle. Through petroleum combustion, fossil fuels burning fossil organisms in the ocean. And that's the ring!
Go.
Oh my God.
and geological